Great. We're talking about recursive function, right? So function that calls itself, okay? Function that calls itself is called recursive function. Now, what does that mean? So what I'm trying to say is, let's say you have a function called, called say hi or something. And here I do print hello. Okay. And after print hello, okay, this function again calls itself, say hi. This is recursive. Okay, the function calling itself. Say hi is a function here, and this function calls itself. Okay. So obviously, when I run this, nothing will happen. Okay, because this is just a definition, correct? But now when I call say hi, so what happens? Line number 7 is the first line to get executed, executed by Python. And then after this, it goes to line number 3, goes in 5, and then it calls itself. So goes to 3 again. So it becomes kind of infinite kind of loop. Now this is different than loop because in function, okay, when you start from, let's say, line number 7, again you come back to line number 7. You don't come back to line number 8. So come back to line number 7. So in this case, what happens, like when you say hi and say hi, again you call say hi, the first say hi is not complete because you have to come back here again. And before, it's like this, like say, you are in office, okay, and then you're supposed to go to another location for client location, let's say, for some reason. You go to your client location, and then again it says, okay, you have to go to second location. Then you go to third location, okay, and you have to get something back. That means, let's say if you are at location 4, okay, then you can't come back to office directly. Because every time when you have to go, you have to come back to this location because they are the task that has been given to you. So let's say if L4 is your last location, then from here you have to come back to L3, again come back to L2, L1, and then only you can go to your office or let's say your home, right? So, okay, so here you have L1, L2, L3. Imagine this is again L1 itself. So, okay, you keep executing the same stuff again and again and again and again. Okay, and as I said again, when you are at the last step, you can't come back to the first step immediately. You have to go through all these, then only you can come back. So in this case, okay, if I run it now, so what happens? Okay, see, it says hello and then again calls itself. Again, it goes to print hello and it does. There is no way to stop this, right? We have not stopped this. So what happens? Okay, it goes on. That's why it says maximum recursion depth exceeded. So it can handle probably up to 993 recursion. Okay, it can go up to let's say from L1 to L993. Beyond that, it can't. Okay, because it has to store information, right? So that you come back again. You have to trace back to the same route. So, so it actually given you error. But this is what recursion is. Recursion is where you call yourself. Now, you have to have some ending condition, right? You have to have some ending condition because if you do not have ending condition, you'll get into this kind of situation, infinite recursion. Okay. So there will always be at least one condition to end. For example, I can say n here, okay, and what happened? Okay, it's a little slow. Okay, I'll say n here, and I'll say if n greater than 0, okay, if n greater than 0, okay, then, okay, let's say then you print this. System is getting slow and I have few applications open. That's what is making it slow. So I'm saying if n is greater than 0, that's when you print hello and call itself. Okay. Otherwise, that means if n becomes 0 or less than 0, then I'll say return 1 or something. Okay. Return 1 means the function is coming back, right? That's how, function ends with return value. Now here I'm passing n. So obviously what I'll do, I'll say n minus 1. Because somehow the n has to come back. Let's say I put n equal to 20. So when it goes here, your n is 20, correct? And if n is more than 0, then you're calling itself. And then now you're calling with 20 minus 1, 19. Then it calls itself, then becomes 19. Comes back here, becomes 18. So as long as n is more than 0, you're playing with this area. The moment n becomes 0, that means the condition becomes false, it goes to else, and now you return 1. No longer you're calling itself, you're calling 1. So when you write a recursive function, now when do you do recursive function? Recursive function is used when you have a pattern like a recursion pattern, right? Here example, I want to print hello multiple times. Okay, so there's a pattern. You want to print hello, print hello. Every time you want to execute the loop, not loop, function, you want to print hello. So this is case where you can use recursion. And always, okay, when you write recursion, be careful about the ending condition. Okay, you don't want to get into infinite recursion, which will again create problems. It will give you error. So in this case, okay, see, so it is printing hello, hello, hello as long as n is more than 0. The moment n becomes 0, it stops. It says return 1. So it's like this, okay? You start from here. This is, okay, the main calling function. And then you say L1, you come here. Then again you say L1. So here it is L1 of 20. Okay? Then here it is L1 of 19. L1 of or L, L1, right? So we'll call it as L1. L1 of 18. Okay, so on. Okay, finally you have L1 of 1. When it is L1 of 1, again you comes in, okay, inside this, and then it says L1 of 0, right? So you will say L1 of 0. Next time it goes here, now it is n is 0. So n is not more than 0. You come back to else. You come back to else here. Yeah, we'll continue. Okay, so you reach L1 of 0. When L1 of 0 comes, this condition becomes false. You come here. Now you say return 1. So now you're tracing back. So this will be replaced with 1. Then you come back again. You're replacing this with 1. You come back and finally you'll come back to line number 12. You come back to 0. So this is how the function works. Okay. So we can't use recursion for, all kinds of problem. We have to use recursion where actually recursion makes sense, right? So one, classic example is to find factorial of a number, right? This is one uh, factorial of a number. Now, if I have to write factorial, how do you write factorial? Let's say if I have to say 5 factorial, right? So 5 factorial can be written as 5 into 4 factorial, correct? 5 into 4 factorial. Now 4 factorial also you can write it as like 4 into 3 factorial, correct? 3 factorial you can write it as 3 into 2 factorial, correct? So this is how you can expand the factorial, isn't it? 5 factorial is 5 into 4 factorial. 4 factorial is 4 into 3 factorial. 3 factorial is 3 into 2 factorial. So it goes on like this, isn't it? So this is classic case, okay, of implementing this using say, recursion. So I'm going to create function called recursion or factorial, I'll call it, okay? Best. Factor, I'll call it, okay. Here you take n. So I want to find factorial of n, correct? So factorial of n can be written as how? How do we write it?
N into n minus 1 till 1.
Okay. So if I say if ending condition, right? First ending condition. So if n, okay, is less than equal to 1, then factorial is 1, correct? If n is less than or equal to 1, 0, 1 or minus 1, whatever, then factorial is 1. Else, okay, then I have to call factorial. Factorial is n into, okay, factor of n minus 1, correct? So factorial 5 is 5 into 4 factorial, correct? So 5 into 4 factorial, and this we will return. I will say return. Clear? So we are saying n if because see 2 factorial is 2 into 1 factorial, and 1 factorial we replace by 1, isn't it? 1 factorial we replace by 1, right? So similarly, if it is 1, then you return 1. But for rest of the thing, okay, you are saying n into factorial of n minus 1. And it goes here n minus 1. Then it comes here. So it is n minus 1 to n minus 2. That's how it keeps on going. And now, so okay, so this is how you expand. Okay, 5 into 4 factorial, 4 is 4 into 3 factorial, 3 is 3 into 2 factorial into where you stop. So this is your ending condition. Here there is no more recursion. We stop here. Now, okay, when you now you return, you come back. So you come back, it becomes 1 into 2 into 3 into 4 into 5. This is what you get when I call here, let's say result equal to factor of 5. And then you can print the result.
Sapnil, I have a question here. So separately, you don't need to do n minus 1. It's already taken care in the 23, is it? The line 23. Because what I was saying is like after 5, 4, 3, 2, 1, right? That's how the multiplication should be.
Correct. So this is how you're multiplying, isn't it? So
Yeah.
now, so instead of saying 5 into 4 into 3 into 2 into 1, okay, we are
Yep.
saying 5 into, then repeat me. So it's like repeating itself, isn't it? It repeats, factorial will repeat. So, so now second iteration, the value of n becomes n minus 1.
Oh,
Then
so automatically it picks up n minus 1 there.
yeah, because you're giving here, right? So yes,
Oh,
automatically.
okay. Changing. Oh, okay, okay. So the line 3 is very good.
Yeah, a second iteration, this n becomes the previous n minus 1.
Right. Got it. Thanks, Sapnil, for the clarification.
No problem. Okay, so this is how your function work. Okay, so recursion function works, function calling itself. And there are some occasions, not every time you can use it, only when you can find a recursion pattern, that's when you use it. Okay, so with that, okay, so there are a couple of other applications of functions. You can use a different way of using functions. Let me show you that. And then with that, we will wrap up. So let's talk about another example here. So let's say I write a function here. Okay, I call this as def f1. Okay. Now in def f1, I have def f2 inside f1. And here I'm saying print I am in F2. F2, which is inside F1, let's say. Okay. Then I'm going to go here and say print first line of F1. Now, if I call F1, what happens? Okay, if I call F2, what happens? Since F2 is inside F1, function F2 is inside F1, okay, I can't see F2. So I can't call F2. So if I run it, okay, F2 is not defined because F2 is inside F1, not visible to me. It becomes a function inside a function and it is available only to the outer function. I can't call F2. Okay, it says call F1. Great. Now if I call F1, okay, so okay, it goes here. Now you see, this is the definition, right? Definition will not be called until we specifically call it. Okay, we are not calling F2. So this is not defined. Okay, F1 is called. So now if F2 is defined, but it is not called, it is not available. Right? Now again, if I call F2, right? Now F1, F2 is defined inside F1. Correct? So if F1 is defined, F2 is defined inside F1, it is not visible even now also. Okay? It is available only for F1. And whenever you want to call it. Now, if I want to call F2, and now I say print second line of F1. Okay? So you're calling F1. F1 is again calling F1 function. This is the definition here. So now it knows that okay, F2 is created. First line of F1. Now we are calling F2. When you call F2, F2 is called, and now you have second line of F1. Okay. So what happens sometimes, sometimes you do not want user to know that you have multiple functions. Okay. You do not want user to know that you have multiple functions for doing same stuff. For example, okay, let's say I want to call a simple function on the right. Okay. I want to call it, let's say, def calculate. Okay. Calculate, you pass num1, you pass num2, and you pass operator. Okay. And inside this, okay, you define, let's say plus. Okay. Plus will take n1, comma n2. Okay. And you will say return n1 plus n2. Okay. Now you can create another function, difference n1, comma n2. Okay. Return n1 minus n2. And you can write more functions like this. Okay. So what happens when you call this calculate? Okay. So I'm saying calculate 5, comma 10, comma plus. Okay. And next time I'll call calculate 5, comma 10, comma minus. Okay. And here I will say result equal to and I'll say print 1 dot result equal to the result. And I call this 2. Now, see, whether you are doing addition or subtraction, for the user, for the end user, for us, it is still calculate. We think that calculate is doing both these operations. But actually, it is not calculate. You have plus and a difference, okay, which are actually doing the calculation. So what I'm doing here, okay, I'm defining this. Now I will say if, okay, operator equal to plus, then, okay, then I will say output, okay, out, O-U-T, output equal to, I'm calling plus I will say n1 comma n2. Okay. Here I'll say if op equal to minus, then output equal to diff. Okay. And then you say return output. Okay. Now, I just said, okay, for a user, this is what we will have access, right? We only know there's a function called calculate. We don't know what is inside, right? For example, print. We know print gives, will display onto the screen, but we don't know what is inside print, right? How it is implemented. Okay. And the reason is we don't need to know. We just need to know, okay, what print does. Okay. What's the meaning of print? We don't have to know how it is implemented. Implementation can be left to the programmer who did it. In this case, for you only worried about, okay, there's a calculate. Calculate will calculate the value for us, whether it is addition or subtraction. Inside this, they are going to handle, they'll have different function. Now, these functions are available only to this function, calculate, right? So depending upon how, the input value, it is calling one of these functions. So this is one application where as a user, you don't have to get into details. Calculate will do all the job for you. And you can write n number of functions, right? And for different operator, you can have different function. But as a user, you think one operator is enough. One function is what I need to remember, calculate. I don't need to remember 10 functions for doing 10 different things. Right? So yes, so this is one application of where you have function inside a function. We call this as function decorators. Okay. And there are other properties as well. You can call a function just like you call a variable to a function. You can call a function. So same function I can write in different way. Okay. So what I'll do, I'm going to paste this here so that I can share with you later. And let's say these functions, okay, we write outside. Okay. So these are your main function, right? Now, okay, so this is your main function here. And calculate, okay. Now calculate, you have n1, n2, and instead of operation, I will have, let's say, function. I'll call this as func, okay. So you are passing 5, 10, and instead of plus, I will pass this function name. Okay, I don't need, I'll delete this. So I'm going to pass plus, I'm going to say plus. So plus is a function name. I'm saying calculate, take this and call plus function. Just like you pass variable, right? This is how, I'm passing function name, diff. Now what it does, okay, here it will simply say, okay, you don't have to have if condition. You will simply say here, okay, output equal to func of n1 comma n2, right? So see here, I'm passing two values and passing the name of the function, just like this. So when it comes here, n1 is 5, n2 is 10, and func is plus. Now I'm saying function func. So func will be replaced when you call plus, it will be plus, and when you call diff, it becomes diff, right? So it'll give you same result. You see that? So you can pass function name also to a function just like you pass variable names. Make sense?
This is a good one, Sapnil. On line 10, right, you don't need to put that in the bracket as a function.
Correct. We are passing just the name as it
Name.
is. Yeah,
Okay.
because we are not calling it, correct? But we are
Yeah,
calling it here. So when you call it, you have to pass bracket.
got it. Okay.
Yeah.
Interesting. Yeah. Thanks.
Yeah. No problem. Okay. So with that, we complete our discussion on functions. Now we will get into um, class and objects. Okay. But before we get into class and objects, there are a couple of other properties. Let's talk about. Okay. The properties about list. We call it as map, filter, and reduce. Okay. Map, filter, and reduce. These are useful properties of list. Now that we know function, okay. And see, and we have not done one more type of function. Let's do that. Okay. So we have something called as, now we have seen inbuilt functions, right? What are inbuilt functions? Predefined functions, correct? Which is available for us to use. Then we have user defined functions. The functions that we've been doing for last 2-3 days, right? 3 days, where we are creating our own functions, correct? Third type of functions are called anonymous function or one-line function. Okay. I might get the name of anonymous wrong. And N-U-O-U-S. I don't know. Is that correct? Anonymous. Okay. Okay. I have to go and do.
That's okay. Yeah.
But you get it what I'm trying to say, right? So it's English word anonymous. Okay. Let me quickly get the meaning from internet. I think I was close, not very close.
There should be M, I guess. Yeah.
Yeah,
MOUS.
anonymous. Yes. Okay. So this is called anonymous function or one line function. Okay. So anonymous function or one line function, okay, as the name suggests, it's you don't have to give name to this function. Okay. Doesn't need name. Okay. And also it is one line function. Okay. We also call this as lambda function. Anonymous one line or lambda function. Okay. Same. It means same. Okay. So how do we do is we we start with writing lambda. Lambda is the keyword. Okay, so lambda indicates that you are doing an anonymous function. Okay. Now lambda, okay, lambda followed by, okay, you can pass, let's say 5 comma 3 or 5 comma 4. You can pass any number of values. You can say 5 comma 4 comma 3 comma 2, comma whatever, right? Then you have colon lambda 5 comma 4 colon and then the return value. So if you have a function, so any function when you write something like right, define f1 and you say a comma b and then you say return a into b, for example. Okay, where you do not have any content in the body. Okay, where you do not have any content in the body, you can perform the function in one line. We call it as, we can implement using lambda. Okay, you don't have to write def and 2 lines. So remember, let's say if you cannot implement in 2 lines, okay, you have to write few lines here, few lines here, few lines here, then we can't convert this function into lambda. But when your logic can be implemented in one line, when your logic can be implemented just in one line, we can use lambda here or to find multiplied, product of two values. So lambda 5 comma 4 colon 5 into 4. This can be written using lambda or 5 to the power 4, right? So logic can be implemented in one line. Now here, okay, I can call it as my func1, for example. Okay, so my func1. Now, okay, so here we don't pass the value directly. This is just to tell you that this is how we implement it. So I will call this as, let's say, A and B, and I call this as A and B. Now, my func1, okay, is lambda function. So, I'll probably write this one also so that. Okay. I'll call this as my func. Here we'll call this as my func2. So above my func1 can also be written as. Okay. We'll give hash. Can also be written like this. Okay. So now next time onwards, okay, you can simply call, say print 5 to the power of 4 is. You can say my func2 and then you pass 5 comma 4. So when you say 5 comma 4, my func2 is this. So A will take 5, B will take 4, and it will return you A to the power 4. 5, A to the power B. So 5 to the power 4. Okay. So these kind of functions where you can write the return logic in one line. Okay, you can implement using lambda. Okay, this is your anonymous function. Okay, so why it's called anonymous? Okay, now here we have given it a name. You can implement it without giving a name. Let's say if you have to implement it at one place and you don't want to call it again, you can implement it without giving it name. So we'll see that, okay, by implementing, there are three applications within list. Okay, we call them as map, filter, and reduce. Reduce. Okay, what's the application of map? Okay, now let's say, okay, you have a very large value, okay, and you want to apply some logic on it. Okay, you want to apply same logic on all the values of a list. Apply same logic on all the values of the list. Okay, that means, let's say you have data in feet, you want to convert into meters. You have currency in dollar, you want to convert into rupees, right? So you have multiple values. Okay, let's say you were tracking price of a stock, okay, for last 30 days. So you have 30 values of stock price. Now you want to convert all the 30 values into rupee. So the logic that you'll apply, okay, like let's say you want to multiply with 80, for example. So if you're multiplying with 80, same logic you have to apply on all the values, isn't it? So that's where we use a map. So map is when you want to apply same logic, okay, on multiple values. Same logic on multiple values. Okay, so let's say multiply all the values by 76. That's the logic. Okay, you have distance in feet, you want to convert into meters, right? So you are multiplying that with 3 point something, right, for all the values. So we call it as map. Filter is again, so you have values in the list and you want to filter out some values based on some conditions. Okay, filter out values in a list based on a condition. For example, okay, negative values, remove, okay, negative values. Okay, so you have a big list of values. Okay, you have like 5,000, 10,000 values, and you want to filter out values which are odd numbers, values which are less than 0, values which are less than 5. Yeah? So you have a condition, you apply that condition on the entire values of the list. Okay, so that's where we use filter. Now reduce, okay, as the name suggests, okay, you have multiple values and you want to reduce all the values to a single number. Reduce multiple values in a list to a single value. And to reduce multiple values in a list to a single value, obviously based on some condition. Let's say you have 10,000 values and you want to perform addition of all those values. You want to add 10,000 values, or you want to multiply all those 10,000 values. So you are applying same logic on entire data to get one answer. Okay, so let's say you have marks of your graduation subjects. So let's say you had 30 subjects and it has 30 values. You want to find total of those 30 values. Okay, that's when we will use reduce. So we'll stop today. Okay, we will, with fresh mind, we'll talk about these three things. So so remember, these are properties of list. Okay, values have to be in a list, and then we are applying a common logic on this. Okay, so same here also. See, we're applying a logic. Here also we're applying a common logic, and here also we're applying a common logic. Just that the expected outcome is different. Here, if your input is n values, you get output n number of values. Even here, input is n number of values, output will be more values. Output is also a list, but definitely it will be less than n number, right? Because you are filtering out some values from it. So it will be less than n, but still you will have a list of values. But here, you give a list as input, but you get a single value as outcome. Okay, so we'll see that. Any questions before we wrap up?